Okay, students, today I will discuss about chapter 4 because many of the students were absent on last class. So I will open chapter 4. So what I discussed in the classroom is up to chapter 4.2. Okay, so I'll repeat that thing. So chapter 4 or module 4, physical layer. Okay, so going into physical layer, we just revise the layers in OSI model and what are the PDU, what is the content of each PDU. Okay, so go here. So here purpose is there, physical layer characteristics. We'll go for first two in today's class, remaining after midterm. Okay. The first thing, as you know, the OSI model is a reference model. Okay, and TCP/IP are reference models. So, what is reference model? How the network is working, how you are connected to network. Actually, is based on these reference models. You should know. Okay, gets an idea based on the reference model. Okay, so OSI model has 7 layers. Application is a 7th layer. Presentation 6th layer. Session layer 5th. Transport is 4th. Network layer is 3rd layer. Second layer, layer 2 detailing layer. Physical is the layer 1. Okay, and in the case of TCP/IP, we have number of layers is reduced, any 4. So application presentation session in the OSI model combined to form application layer in TCP/IP. Transport layer in OSI same as transport in TCP/IP. Network layer in OSI is now internet layer in TCP/IP. Data link and physical layer in OSI combined to form network access layer in TCP/IP. Now there is a concept called as PDU. So PDU means, I told you, it's a part of encapsulation. So whenever you are adding data, okay, add the header along with the data, we call it as PDU. Okay, whenever we add some header information, some protocol information on top of data, it becomes PDU, protocol data unit. Example, when you are sending a data, you are not sending just the data. You may be typing www.netflix.com, but actually this data is being added with many information like IP address of the computer, port number of the computer, MAC address of the computer, and all like that. Okay, so that is PDU. So here, application presentation layer and session layer, all these layers have only one PDU data. Okay, transport layer, its PDU is called as segment. So what is inside the segment? Port number. Port number yani which port the client is listening. Like window, we open many windows, which window it's open for getting the data back from server. And in server case, server will have many protocols, right? HTTP will be there, email will be there. So which one you are talking to, that is you have to mention port number, destination port number. So transport layer has data plus port number, that is called as segment. Then when you go to network layer, the PDU name is packet. Mr. What is packet? So what we do in the network layer, along with the data and segment, we add IP address of the source and destination of sender and receiver. Okay. Then data link layer, the PDU name is frame. Mr. What contains frame? Frame contains mainly MAC address of sender and receiver. And finally, at the physical layer, all informations are converted to bits, binary 1010. So in this picture, what you should understand, we are going into physical layer. Before that, we should know what are the layers in OSI model: application, presentation, session, transport, network, data link, physical. By heart all these layers, because to discuss about physical, we should know all the previous layers. Then at TCP/IP, we have only 4 layer: application, transport, internet, network access. Okay. And PDU means, I told you, the header information added on top of data. So for the application presentation session, there is only data. Transport layer, the PDU is called as segment. So segment contains data plus port number. Okay. Network layer contains packet as the PDU. So packet contains the previous data plus segment, any port number, plus I add IP address of sender and receiver. And the data link layer, I add MAC address and it becomes frame. Finally, the physical layer, all these information, frame information converted to bits 1010, because computers understand only bits. Okay. So who is doing this conversion, bits conversion? Physical layer. Okay. So see, we'll go for the first slide in your chapter For purpose of physical layer, why do we use physical layer? Okay, so before you make a connection to any net, before you want to open any network, what you need is your device, either mobile phone or your laptop or your computer. It should have been connected to any network. Example, Isa want to open a website in his mobile phone. Okay, so he cannot simply type the website netflix.com in mobile phone. What he needs first is he want to make a connection, wireless connection to the network or the router. Same case is Abdul Aziz want to for his business purpose, he want to open a website in his laptop. So for that, what we need is the laptop should be connected to any network, either wired or wireless, should be connected to network. Then only we can do. That's a physical connection is very important, right? Then wired or wireless connection we need. Then NIC is a very important device. NIC means Mr. Network Interface Card. If you want to connect a computer or a mobile phone to any network, that computer or mobile phone or laptop needs to be installed an NIC card. Okay, see here, I already shown this NIC card in the lab. Still I am repeating. This is the NIC card, actually wired NIC card behind the desktop computer. Okay, so without installing this card, I cannot connect my computer to any network. So at the side back side of this one, we connect the cable. Okay, this is inside the CPU. This is wireless NIC card. In the laptops and all, we have wireless NIC cards. Okay, there are wireless NIC cards and wired NIC cards. Okay, NIC card means network interface card, a card used for interfacing, connecting your device to network. Mobile phone also have NIC, that is wireless NIC. Ethernet, LAN or Ethernet or wired NIC is available in desktop. Okay, now can I have more than one NIC in a computer? Yes, mister. I can have more than one NIC. So how we know this more than NIC, one NIC? What I will do when I go to my computer, when I type CMD, I can get ipconfig/all. When I do this, if you have, you can see many adapters, wired adapter, wireless adapter, like that means you have many NIC cards available. Okay, so the command used to display the details of NIC card, details of IP address, MAC address, it's ipconfig/all. First thing is desktop computer name, Windows desktop. Okay, then we have Ethernet adapter, Ethernet, the physical address is C85B76, any MAC address. Okay, then we have one more MAC address 00FF64, another one 0A0027. So here a machine may have many NIC cards. Okay, many NIC cards. So we have many MAC address. Okay, so here wireless adapter, again another one 76DF. So here a machine may have not only one IC, multiple NIC cards. Okay, this chapter, this page tells like this one. Okay, like they need a physical connection before connecting to the network. It may be wired or wireless network, and before that any device needs NIC card to be installed. Then only we can connect to the network. Okay, then again discussing about the physical layer. Okay, so here what we discuss in the same picture, go back to the same picture. The physical layer is the only layer which transmits or transports bits, okay, the data through the cable as bits done by physical layer. Okay, and how the physical layer do this? Physical layer receive, accept or get frame from data link layer. See here, what is the layer above physical layer? Data link layer. So what data link layer is created? Frame. So this frame now go to physical layer, and what the physical layer will do, whatever data in the frame is available, it will be converted to 101010, because computer understands only 100. Okay, so that is done by physical layer. First thing, convert the frame from the data link layer into 1010 by physical layer. Okay, that's what written in this slide. Okay, now characteristics of physical layer. So is that purpose done, then characteristics. Okay, so before that, see here we have 7 layers. In that 7 layers, first 6 layers are hidden. Okay, faded or hidden, because these 6 layers are implemented in software and governed by a organization called as IETF. Only layer which is implemented in hardware. You know hardware software, hardware implementation only done for physical layer. It is governed by many organizations like ISO, EIA, ITUT, like that. Okay. So which layer is implemented? Which OSI layer implemented in hardware? Yani physical layer. Remaining all layers in OSI model, application, presentation, session, transport, network, data link implemented in software. Okay, remember this. Only one layer implemented in hardware is physical. Why it is like that? I will tell you. Okay. Here we have all the protocols coding, but here we have the cables, the devices, the media, the port. That's why it is hardware. Okay. Now, see here, physical layer has three functions. One is physical component, then is encoding, then is signaling. Okay. So first one, physical component. That means hardware devices we need to connect with media and other connector. I will show you a simple example. Okay. So see, this is the backside of your desktop computer. This is LAN port. It's a physical component. Okay, LAN port. Into the LAN port, you will connect the LAN cable. This cable is another hardware component. Okay, so this is LAN port where we connect the LAN cable, and this LAN cable also has two parts. See, this is a raw, the original cable. That cable has multiple small colored lines. Okay, multiple orange, white, blue, white, green, so many colors. One day we will show you. I'll show you this cable inside structure. Okay, now how this cable is inserted into this connector, this is called as RJ45 connector. Okay, so actually when you buy the cable will be like this. Then what you should do, we will be removing the one end of the cable, and we see the colors. We have to straighten these cables with different colors, pair them, then we add this into the connector. This is called as RJ45 connector, and this process is called as crimping. Technician will show you how to do. Okay, as I told in the classroom, I told Isra in the classroom, sorry, not Isra, Isa, when you are going to buy a cable, say if you are going to a particular shop in Shinas or Sohar, and you're asking the guy who may be Malwari or Bengali, okay, asking him, I want a LAN cable to connect my laptop to the Wi-Fi router which is in some other room. Okay, that case he will be taking the cable, how much meter, so 1 meter, then he will cut the cable, then he will straighten the multiple colors, okay, lines, then he will add that into a machine where he will fix the cable into the RJ45 port. This is called as crimping. So for that we should be there, you should see what he's doing. Don't go for as I told him, don't go for eating shawarma. Okay, so stand there, watch how he's doing. Or we will do this after the midterm. We already planned, but we don't have time now, so we'll do this after midterm. Okay, this is RJ45 connector. After crimping, what happened, this cable will get inside exactly in this RJ45. It looks like this. Now this will be connected to port. These are all hardware components. One more thing is your router is a hardware component, wireless or wired router. Modem is a hardware component. All these are physical or hardware components. Okay, so media, wired or wireless media, straight through, crossover cable, copper cable, fiber optic cable. Then we have wireless router, wired router, modem. Then we have switches, routers. Then we have RJ45 connector. We have ports, we have cable. Everything is crimping tool. All are physical components. Okay, encoding signaling means, convert the data into coded form. I'll show you what's that encoding. Signaling means whatever data we have 100 or whatever coded data, we should convert that into a signal. Say if I'm using copper cable, I should convert that data 100 into electric signal. If I'm using fiber optic cable, the data 100 convert into light signal. If I'm using wireless media between my mobile and wireless router, I convert the information 10 into wireless signal, radio frequency signal, RF signal. Okay, now what is encoding? Here encoding means actually convert the data into a coded format. Coding, so encoding means convert the binary into a coding format so that other computer understand, next device understand. Okay, encoding means convert stream of bits or 100 binary into a format understandable or understand by another device. Okay, so recognizable is very difficult means, so we'll write understand. Okay, understood by next device. Okay, encoding means convert binary 10 into coding format which other computer understand, baba. Yes, now again go back to slide. Okay, now see here an example. I want to convert 0 1 0 0 1 1 0 into this format. Okay, this is coding format. The name of the format is Manchester encoding. Manchester. If I ask you what is encoding, write the definition. Converts bits into format. Okay, and what is example? Manchester encoding. Manchester, you know that football club, so remember that, boys, you can remember easily. Manchester encoding. Okay, encoding convert the bits into a format. Okay, for the maybe. Okay, format enough. Okay, then encoding method example is Manchester. Then what is this, mister? How this 0100 converted to this method, I will show you. Okay, so here I have a int. Okay, here 0 means start high, at the middle of the cycle go low, and like this. 1 means like this, start low and at the middle go high. Okay, like this. 0 means like this symbol, 1 means this symbol. Okay, here I have one example, 0 1 0 0 this one. Okay, so what I will do, how do I draw is, 0 means this symbol, right? So see here, what I will do, start from the high, then middle, go low. What about 1? Start low, at the middle of the cycle go high. Again 0, start high, at the middle go low. Again 1. Okay, we want to start at the low, right? So this one 0 is ending, then after that 1 will start at the middle, low. Okay, middle it goes high. Again when it becomes 0, start high at the middle. Okay, at the middle go low. Understand, this is how you draw the Manchester encoding. Okay, 0 means start high, at the middle go low. 1 means start low, at the middle go high. 0 means again start high, at the middle go low. 1 means again start low, at the middle go high. 0 means start high, at the middle go low. Like this you want to draw. I give any number, you want to draw the paper. Okay, so here again I go back, check this example what is given in the NetAcad or the PPT. 0 means start low in the middle, sorry, start high and in the middle go low. 1 means start low, at the middle go high. 0 again start low, at the middle go low. Again another 0 means start at the high, at the middle go low. 1 means again start low, at the middle go high. Again 1. So what I will do, I will start at the low, middle go high. Understand? 0 start at high, middle go low. This is Manchester encoding. Okay, if you want more example, you can contact me or you can ask me in the classroom. Okay, or in my office. Now signaling means how the ones and zeros are represented in the medium. Yani how do these ones and zeros shown in the medium. Okay, so method of signaling depends upon the medium. Example, if I have a copper signal, copper cable. If I am using copper cable, means I will convert 100 into electric signal. See here, 1 means high electric signal, 0 means low electric signal, 1 means high electric signal, 0 means low electric signal. Okay. If I am using fiber optic cable, 1 means, fiber optic means information is sent as light. Okay. So if it is 1, it will be light on, LED on. 0 means light off. Okay. 1 means again light on, 0 means off. This is what? Fiber optic cable. So in fiber optic, 1 and 0 are shown in or represented by on off light. In the copper cable, 1 0 0 1 or 0 represented as electric signal, high or low. In fiber it is light. Okay. Then wireless or microwave means it will be wireless signals. Okay, like RF, radio frequency signal. Okay. Now we have some definitions. Bandwidth. Okay. So bandwidth means, so whenever you go for if you want to get an internet connection, so Isa is telling Mr. I have internet speed low. So what you should do, you'll go to the Mantle building or Urudu building or Urudu office. Okay. Then tell them I need fast internet. So they will ask you what is the bandwidth you need, Mr. So bandwidth means capacity at which a medium carry data or how many bits transmitted in a second. Okay. So here nowadays when you ask when you ask someone, they will say I have 100 Mbps connection. So what is that 100 Mbps? Yani the speed of the internet, how much bits transmitted per second. So let me check my speed of internet in my computer. What I will do, I will go to the, see, I always blame you. See, for me also the home page Netflix is coming. Okay. So everybody watch, right? Shina's college is there, but Shina's college is there for me at least. WhatsApp is there, Google is there, YouTube is there, Cisco is there, then fast.com. This is the one website which I use for checking my internet speed, fast.com. Okay, fast.com. I can check the internet speed here. Sometimes it also daytime it's low, so it's showing 9.6 MB. Now it's showing 9.7 Mbps. Actually, it is almost 50 Mbps, but sometimes it's very slow daytime. Another method is ookla.com, right? Ookla is another method. Okay, again I have the tool also, Ookla. Okay, that you can check Ookla, ookla.com, I think. Okay, so here I use fast.com, fast.com or ookla.com to check the internet speed. So it's showing 9.7 Mbps. Mr. What is Mbps? That's a bandwidth, Baba. So Mbps, kbps, like that, what's that means? Check here. The bandwidth is measured in different units. Start with, initially when I was kid, the internet was actually 1 or some kbps or bps, yani bits per second. How many bits transmitted per second? Fundamental unit. Then came kbps, 100 kbs, yani big one that time. Okay, one picture will take at least 15 minutes to open. Forget about video. Video will not open, Baba. So kbps means kilobits per second, yani 1000 bits per second. Mbps, nowadays we are having Mbps. So M means mega. So 10 raised to 6 bits per second. Then came gigabits per second, Gbps, 10 raised to 9. Then now this one's research going on for TBps, terabits per second. So we have 10 raised to 12 bits per second. So go through this BPS, KBPS, Mbps, like that. Okay. Then latency means delay, amount of time for the data to travel from one point to another. So amount of time taken by the bit to move from one place to another. Okay. Throughput means measure of transfer of bits across media or a given period of time. So a particular amount of time. So 1 hour or 30 minutes, how much bits transferred. Okay. Goodput means usually we will say that I have 50 Mbps connection, but you will not get 50 Mbps every time. See, I also have, say, they told me you will get 50 Mbps, but every time I am not getting 50 Mbps. Sometimes I am getting 3, and what I am getting is now only 9.7. Okay, because this is the actual speed. That actual speed is called as goodput. Okay, Mr. Why it is happening? Why 50 Mbps, which is guaranteed by the Omantel, you are not getting 50? Because the actual speed is equal to the good put is the actual speed equal to throughput minus traffic overhead. So whatever you have minus traffic is there, no, this will be some traffic, amount of data will be there more, then we have more data, then we have some data loss happening, signal loss, all those, because of all these things my speed will go down. That is actual data transferred. Okay, that's good push. Okay, these are the things I taught in the theory part of chapter 4. So first thing, OSI model 7 layers, by heart these layers, then PDUs, by heart this TCP IP, by heart these layers. Then we have what is the use of physical layer. Okay, then we have which are the hardware, only one hardware layer physical, remaining all software. Why? Because we have cables, connectors, wireless devices, ports, then encoding, signaling. Encoding means convert the data bit into a format, okay, which the other computer understand. Okay, example Manchester. Remember about your football club Manchester. Boys, you will definitely remember Manchester encoding because it's a football club, right? Then how do we represent 0 1 0 0? This example like this, I will give many example. Please draw this and understand. Easy, you can draw this. Okay, then we have signaling. So how do we convert the data 100 into the cable? We need signals. Okay, that is either copper means copper, see, copper means electric signal, fiber optic means light signal, wireless means RF signal. This is what I teach in the last class. All of you, please watch the video, do the signaling yourself. Okay, I'm stopping this video. Let's see it's uploaded or not. Okay.